Welcome to Session 2 for the NASA Aquarius Data Training Webinar Series. This is your host, Jennifer Brennan. I've got 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started here. What I'll do first is begin by going over a few logistics related to this webinar. To ensure best audio experience, the conference has been placed in silent mode. However, if you have any issues or questions, what I'd like for you to do is enter those into the Q&A pod located on the lower right-hand side of your screen. This works like a chat. The webinar is being recorded and will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a couple of days of completion. What I'll do is I'll try to get at least the direct link out tomorrow. I will email all participants with these links when Session 2 has been posted. All presentation and video files will also be available for your download at the end of the webinar. Today's session will be 1 hour and 30 minutes long. 1 hour is allocated to the presentation period, with the final 30 minutes being dedicated to an optional question and answer period. As a reminder, you will have an opportunity to ask your questions throughout by using the Q&A pod. Questions will not be answered using the raising hand function, has been disabled. So what we'll do today is after our speakers have finished their presentations, I will provide some closing information. We'll have a couple of polling questions, and from there we'll move to the question and answer period. Okay? All right. So today's speakers are Annette DeSharon, who is the NASA Aquarius Science Communications Lead, and she is located at the University of Maine. Dr. Vardis Santos, the lead data engineer at NASA's Physical Oceanography Distributed Active Archive Center, or PO.DAAC, and Dr. Leslie Smith, president of Your Ocean Consulting and serving as an advisor for this training series. With that, it is my pleasure to turn it over to today's first speaker, Annette DeSharon, who will kick off today's training by going over the session objectives and then also a quick recap for last week's homework. Annette?
Hi, and good afternoon or good morning or good evening to all of you. Thanks so much for joining us. I see from the poll question that was posed earlier that pretty much everybody either attended last week's session or saw it online, so that's great. Thank you so much. So I'm going to start with recapping last week's homework. And so here it is, and not all of you completed it, but I would like to just share with everybody so they will know what folks have been doing on the wiki. Thanks to those of you who did complete the homework. We've got the objectives for the assignment written up here. Explain what you observe in monthly average salinity data, including general patterns from a global or regional perspective, and generate 3 maps of salinity averaged over your birthday month from 2012, 2013, 2014. Look for areas of high interannual variation in salinity. So before I get to some of the data, some examples of the data that were posted, I did have somebody who was on the Aquarius Science team. His name is Dr. Fred Bingham. He's a professor of physical oceanography at University of North Carolina, Wilmington, and he has graciously been looking in on your homework assignments and commenting on them, so we are hoping that you will find some of the insights from Fred to be helpful to you. So here's a couple of examples that were posted last week. Things that were noted by the people who posted these, some saw high salinity correlation with high evaporation areas. Another saw possible year-to-year increases of salinity in some regions, and those are shown here by the circles. Let me grab my thing there. There you go. Here's another couple of maps. This person on the left was looking specifically at the Atlantic Ocean and hypothesizing about freshwater input from rivers over the 4 years that he observed. And then the one on the right was looking at changes in subtropical gyres from year to year. The next couple of examples, they noted that maybe some of the patterns are due to atmospheric circulation changes and impacts of that. And another student or poster talked about changes in ocean currents maybe affecting some of the salinity patterns in the Western Pacific. And this student also put a precipitation map to show some of the correlations between low salinity and high precipitation. And lastly, this person also was looking at precipitation, that's on the right, and salinity on the left. They addressed salinity gradients that we're seeing, the location of the intertropical convergence zone, and postulated that La Nina conditions could be affecting the salinity patterns. So that's just a kind of an overview of some of the homework. We really, if you didn't do it last week, please feel free to do it this week. I hope that those of you who did it thought it was fun and informative. And again, as I said last week, this week's homework was done using the very simple live access server for My NASA Data, but Vardis will be showing you the PO.DAAC version, which is more complicated, accesses a lot more different types of Aquarius data next week. So speaking of next week, here's an overview of the sessions. Session 1 was an overview of Aquarius and some data resources. Today, we're going to dive deep into discovering Aquarius data and accessing it. In the middle of those two talks, there'll be an overview of the step-by-step tutorials, and that will be given by Dr. Leslie Smith. And there'll be, as Jennifer said, an optional Q&A afterward. Session 3 next week will be the demo of Aquarius visualization tools, and I will be spending time talking about some effective communication techniques that I've learned through, mainly through my association with the Centers for Ocean Sciences Education Excellence, COSE. And next week, session 4 will be the virtual poster session, and we're going to ask you a little poll question about that later on. So with that, I'm going to turn it over to Dr. Vardis Santos, who's a PO.DAAC data engineer, and he's going to be talking to you about Aquarius data. Thank you.
Thanks for that. And hello, everyone. This is Vardis from the PO.DAAC, and I'm going to be giving you an overview of how to discover Aquarius data that we host at the PO.DAAC. As mentioned last week, PO.DAAC is the official repository for the Aquarius SAC-D mission. So we maintain all the data sets produced by the mission here, and we archive it, make it available to the science community in general. Okay, so let's get going. So as I also mentioned last week, the gateway to all PO.DAAC data and informational resources are all available through the PO.DAAC web portal. Okay, and how do you get to the web portal? Simply in Google, just type in PO.DAAC, PO.DAAC, and what will come up is our main web page. And through that, you can access data, a range of tools and services for working with data, and also some visualization capabilities that we'll be talking about next week. Okay, so this is the screenshot basically illustrates how the homepage looks like. And there's several ways that you can actually sort of start searching for and discovering Aquarius data. On the main toolbar, there's a menu option that says Dataset Discovery. You can click on that and then go search for data sets that we host by parameter, by mission, by instrument, etc. Okay, but probably the easiest way to immediately start searching for data is simply to use the search toolbar that you can see on the screenshot to the right. And essentially, you can just type in a keyword, and it will search our entire data catalog, okay, for all data sets that match that expression that you've typed in. So in this example, just type in Aquarius, and what you'll get back is a listing of all Aquarius-related data holdings that we have at the PO.DAAC. Now, I just wanted to point out that if you click the little question mark button, you'll get instructions as to how to create more complicated, sort of compound keyword search terms. Okay, so for example, you can type in Aquarius plus project, and that will limit the query to just data sets that are related specifically with the Aquarius mission. So no sort of PI-provided data sets, which if you type in just Aquarius, you'll get a complete listing of everything that has a keyword of Aquarius. So the mission data plus 7 of the CAP, JPL CAP Aquarius data sets. Okay. Next slide shows you exactly what happens when you execute that Aquarius search. And in fact, on this screenshot here, you can see that you can already start adding some additional filters to limit the list of catalog entries that are returned. But by default, when you type in Aquarius, you'll get currently, for the version 4 Aquarius datasets that are available at the PO.DAAC, a total of 105 products listed in this that are available via our cataloging system. Okay, and so that's a lot to deal with, perhaps. And so there are capabilities provided that allow you to sequentially filter down and get to the precise data set that you may be interested in working with. And we call this feature Faceted Search, okay? And it's the faceted filtering capabilities are located on the left panel of the web page that comes up when you execute a search. And so you can filter by, for example, the processing level of the data set. So either a level 2 swath data set or a level 3 gridded data set. Or you can use additional filters such as the resolution, if it's a swath data set, or the grid spatial resolution, or temporal resolution. You can select, this indicates basically the range of products that we have in terms of time interval, okay, for Aquarius. And that little number to the right tells you actually how many data sets, daily data sets related to Aquarius, okay, we actually have available. So out of the 98, out of the total 105 Aquarius data sets listed, 10 of those are daily data products. Okay, and so you get this listing. You've now filtered it down to those items that you're particularly interested in, say a 7-day weekly snapshot, okay, level 3 data set. And then you want to find out more about one of these data sets. So essentially, from that listing, you just click on the hyperlink on the main sort of the long name of the data set that's listed here in blue. And essentially then what you get is a series of dataset information pages, okay, that provide quite a lot of very useful descriptive and other information about the data set that you're looking at. So there's several tabs. The first one that we're looking at is the sort of the dataset information tab, and you can see there the long name is given, the URL. If you want to pass on, if you want to convey to a colleague, oh, I'm working on this particular data set, you just copy this URL there and then email it to him, and then he'll be able to check out this data set catalog entry as well himself. You have a lot of, this is just a sort of a truncated snapshot of what you'll see on the screen, but there's a lot of useful information in here, such as the latency of the data of the data set, the short name, the temporal resolution, spatial resolution, the frequency with which the data is available. And then relatively new, we now have DOIs for all of our Aquarius data sets. So for those of you who are familiar with DOIs, these are digital object identifiers. They're used originally, I think, for publications, but now you can actually uniquely reference a data set with this uniquely registered dataset DOI. Okay, so if you want to use a particular data set in an analysis that you then publish, basically you can cite that by just quoting the DOI and maybe even additionally adding the link to our catalog entry. The next tab, which is perhaps one of the more important ones, is how do you actually get to the data files, okay, so that you can start working with the data. And all of that is under the Data Access tab. And you can see some links are provided and some additional information. So essentially the URL to get to that specific data entry location on our public FTP site, or if you're using the PO.DAAC web service, okay, those links are provided. And some of the other data sets, the level 3 products that we have, will have additional items listed underneath here. And you can see also there's information about the file format, and Aquarius data are all compressed, okay, VZ2 compressed. And then in addition to how you access the data, there's also information on applicable tools that are relevant for this particular data set that you're looking at, and also reader software in MATLAB and IDL that we provide for these Aquarius data sets. The next tab over is documentation, and as I mentioned last week as well, first and foremost amongst those the user guide that has been developed for Aquarius, which is really a one-stop shop, treasure trove of information on Aquarius data, how to access the data. So if there's one document that you read, I advise that you take a look at this. And then there's pointers to other project materials on our FTP site, etc. The other tab that's highlighted here is what is referred to a granule or a file listing. And we'll define some of these terms like granule in a minute. But essentially, it's kind of like an FTP directory listing. You can just click on any of these elements within the browser without leaving the dataset information page that you're looking at, and sort of browse through the hierarchy of data directories and look at data files and resources that are available. So these little numbers in parentheses indicate the number of data files in that 2011 data folder for this level 2 Salinity product. The final tab, and we don't have a slide on it, is the citation tab, but it gives this sort of the official sort of way in which if you wanted to use or quote this data set in some kind of publication, the way that you would reference that. Okay. So there are a few terms that I think it's important that everyone clearly understand when working with Earth science satellite data in general. And so I just wanted to introduce some of these concepts in case people are not familiar with them. And the first of those is the concept of a data set or product level. Okay, and the level really reflects the stage in the data processing sequence that has produced that data product. So in terms of satellite data sets, they range from level 0 all the way to level 4. And in the series of bullet points, I kind of define not necessarily official NASA definitions of what these are, but sort of a more perhaps accessible definition of what these different product levels mean. So level 0 is essentially the raw instrument and telemetry data coming down from the satellite. Level 1 data contains the raw data that's now been processed, okay, to some degree, into orbital or swath data files, okay? And these, in the case of the Aquarius level 1A, contain the instrument count and satellite navigational telemetry data. I just wanted to point out as well that in this column on the right here, I indicate what the file naming convention for that particular data product for Aquarius actually looks like. And there's certain nomenclature and the convention that's applied for all of these Aquarius data products. And what essentially will differ for a different data file is the date information here, okay, for each product type. Level 2 now takes the level 1 data and does some additional processing to it, okay? And again, it's orbital data, so in the case of Aquarius, 15 files per day, each of which contains the actual georeferenced geophysical measurement data, okay? So by geophysical measurement data, we actually now mean the retrieved salinity, wind speed, and other variables, okay, from Aquarius. There's another stage of processing that then takes the level 2 data files and then pools and grids them, aggregates these data and then grids them, okay, into what are referred to as the Aquarius standard data products, level 3 data products, which are all on 1 degree latitude, longitude, spatial resolution for various time intervals. And this little table here below illustrates that, at level 3, we have a range of data products for the different parameters that Aquarius processing returns: salinity, density, wind speed, and ancillary SST. So by ancillary, this is not actual data that Aquarius itself measures, but it's used in the Aquarius processing, and it's important in terms of interpreting some of the salinity fields that we see in these other data sets. So that's why that is included as well. Okay, and in terms of time intervals, we have now, given that we are at the end of the mission, we have a range of time periods for which gridding has occurred. Okay, and we have products for each of those, ranging from daily, 7-day, monthly, annual, and even some quote-unquote climatologies for the duration of the mission. And then there is another thing that you should be aware of. We have basically the combined, so level 3 products based on the combined level 2 data, or and also versions of that just look at the ascending and descending paths of the satellite. And this again, these, I think the typical user would just be interested in the combined product. Ascending and descending is used mainly for the cal-val process in troubleshooting any issues. Level 4, so the Aquarius mission does not actually produce any level 4 data sets, but I'm going to define them here. These are considered to be value-added gridded data files. And essentially what level 4 does, it's value-added because it integrates data potentially from multiple sensors, or applies some kind of more advanced statistical or interpolation procedure in producing the data set. Okay, another very important term that some of you may be familiar with is metadata, and that will be used, that term is cited quite a bit in this presentation. Basically, metadata is contextual information that describes and facilitates the correct interpretation of data values and their quantities. And some examples include, the units. So what a data value, you get a data value in the data in a given data set. How do you interpret that? You need to know, to do that, you need to know what the units of that value are. And that is an example of a metadata element. Okay, and there are various others. So, and metadata is essentially comprised of is a property that is comprised of an attribute and some kind of associated value. So in our units example, the attribute would be units, and the value that it takes is PSU. It's important to understand that metadata exists also at a variety of levels. You have metadata at the dataset level. So all these various fields that I described when covering the dataset information page, such as the short name, DOI, resolution, etc., all of these are examples of dataset level metadata, okay? And the values are actually the entries, the descriptions, etc., that are in that catalog reference. Another thing that everyone should understand is that, PO.DAAC develops and catalogs and archives all of this dataset level metadata. But in fact, we also essentially convey automatically all of our metadata information, okay, at both the dataset and the granular level, which I'll be defining in a minute, to a centralized NASA metadata repository that's now referred to as a CMR, the Common Metadata Repository. Some of you may be familiar with what was referred to as GCMD and ECHO repositories. Well, that has been sort of rebranded and re-architected in the past. Okay, and now some additional terms to define. So we have dataset level metadata, and then we have metadata at the granule or the file level. And it's possible to include this type of granular level metadata because these days science data files such as HDF and NetCDF have the ability to embed that information in there. So these are referred to as self-describing data formats. And within a granule or data file, you have metadata that is global. So that's at the header sort of level, as indicated here. Okay. And then you have variable level metadata. And these are attributes that describe the properties of individual file variables contained in data arrays. And amongst those, you have structural and descriptive metadata. These are elements that describe the data arrays or attributes and properties of the variables themselves. So I just wanted to point out very briefly here that there are now metadata standards that have been developed in terms of what these attributes are and what values that they should take, that have been developed by such as the CF convention and ACDD. And these are very important because they ensure the interoperability of data sets that are produced these days. I believe this is the final slide, and it essentially then shows that you can actually drill into a data variable and actually then look at the data values themselves. So at this level now, we're actually looking at data values. Okay, that concludes this part of the trip and of the presentation, and I'm going to pass it over to Leslie for hers.
All right. Hello, everyone. I'm going to briefly highlight for you a set of resources that we specifically developed for this webinar series. This is a series of step-by-step tutorials, and they're going to be available, they are available in both PDF form as well as videos. And these 11 tutorials are designed to help you access data, customize the data for your own research, as well as create various data products. And the best part is that these tutorials are evergreen resources. So they're going to be around long after the webinar. So things that you may have forgotten, you know, in the weeks and months down the road, you can go back and get a refresher course by looking at these materials. So these step-by-step tutorials are going to cover a lot of different areas within the PO.DAAC, specifically the ones that are highlighted in red here on this slide. So first up, we have the first tutorial is going to be introducing the PO.DAAC. And so this is a lot of the stuff that Dr. Santos just went over. So specifically in this tutorial, we look at data set discovery, data access, as well as some features on the Aquarius mission page. So the second tutorial is how to access Aquarius data sets through the PO.DAAC, and this is going to be the, what Dr. Santos will go over after my talk. One feature about these slides that I want to make sure you guys notice is this box that appears in the top left. This is going to tell you tutorials related to this one. So it'll be tutorials that you should look at beforehand, as well as later tutorials that might require this skill set. So for example, in this tutorial, you'll want to have had the primer in the PO.DAAC website so you know how to get to this data set discovery page. So on the data set discovery page, the tutorial will take you through the filtering and finding the data set you want, as well as the various information you can learn about that data set. The third tutorial will take you to downloading NetCDF file from the thread server. And again, a perfect example, you need to know how to get to this web page for the thread server, and you can do that by using the Access Data tutorial. So on this page, you'll select NetCDF subset, and then the tutorial will walk you through how to subset your data set, both geographically as well as subsetting it through time. So we'll also take you through how to download data through the OPENDAP server, and you can do this from two places, from the Aquarius mission page, as well as data set discovery. So OPENDAP is set up differently than the NetCDF. With OPENDAP, you'll be looking at a file hierarchy, and that hierarchy is going to take you through the different types of data, for example, an L3 mapped data product from version 4 of the data, as well as when those data were taken, for example, the year. And with OPENDAP, you're downloading a specific file in its entirety, unlike NetCDF where you'll be subsetting. So moving on from the PO.DAAC website, we'll take you to some data visualization software. So this is Panoply. It's a free application that you can download off the internet to help you visualize your data. here is what the Panoply software looks like. And so notice to visualize the NetCDF file using Panoply, you'll have wanted to download a NetCDF file beforehand. And I've never actually used Panoply until getting ready for this webinar series. I really like it. It's really intuitive. It makes really clean maps. So I hope you guys like it as much as I do. So speaking of maps, you can create a lot of different kinds in Panoply. The easiest, most intuitive one is probably the longitude, latitude plots. So to make those, within Panoply, you'll select your data set. In this case, I've selected sea surface salinity, and just click Create Plot. Select the type of plot you want to create, and then this is what the longitude time plot looks like, essentially just a global map of sea surface salinity. And there's lots of things you can do to customize your plot, one of which is change the scale range. So here I've set the minimum of my scale range to 35 to really highlight areas with above average salinity. And I think it's really neat how the Mediterranean really lights up here with all the evaporation that occurs in that area. But you can also customize things like add different overlays. For example, you can map out the world's rivers, or you can add contours. Another type of map is a line plot. And so here when you select line plot, you're going to be choosing the value you want to occur on the x-axis, and then your data will be the value on the y-axis. So in this case, I'm going to choose latitude, and my data again is sea surface salinity. So here's what that graph looks like. And then you can also select what data you want to visualize. So you can select the time step as well as the longitude, and you can either choose one longitude or you can choose to do an average of all longitudes across the globe. Another type of plot is a Hofmahler plot. Probably the most traditional style of Hofmahler has the time on the x-axis and latitude on the y-axis. So here's what that plot would look like. And the customization of this plot is going to be very similar to what you can do for the latitude-longitude plots. So you can also compare data sets together using combination plots in Panoply. And so to do that, you're going to want to choose either two comparable data sets. And by comparable, I mean they have the same units. So you could choose air temperature and water temperature if you wanted, as long as both were in Celsius. Or you could choose the same data set and select it twice and just choose a different time step. And that's what the first example will be, is I've selected sea surface salinity twice. And then I've chosen, in one case, I've chosen the time step of August. And then in the other case, I've chosen the time step of January. And so what this is it's combining these two data sets together. And in this way, the way it's doing is it's subtracting pixels from array 1 from those same pixels in array 2. So it's showing me the difference in salinity between January and August. But there's other ways that you can combine data too. And this menu shows you all those different ways that you can combine them, multiply them, average them, merge them. And this last one, vector magnitude, I'll show you as well. So with vector magnitude, you're going to be combining your eastward and northward components of a vector. So you want to make sure you're choosing data with inherent direction, so choosing wind speed or currents. So here's an example of that vector map, and this is water current. So now that you've created your maps, you're going to want to export them. We can do that in 3 ways. You can create an image file of your map. You can create an animation of your map through time. Or you can export your map as a KMZ file. And KMZ is the native format for Google Earth. So Google Earth, this is super cool. You can plot your salinity data on top of a Google Earth globe and then spin and manipulate your globe. So I think this is a really cool feature. And then once you have it mapped onto Google Earth, you can then make a movie of it. There's 2 types of movies you can make, one of which is going to be native to the Google Earth format. And so this can either be done in Google Earth or Google Earth Pro. You simply select the little movie maker icon here, and then after you record your movie, you're going to save it to My Places. Or if you downloaded Google Earth Pro, which you can also download for free on the internet, if you go to Tools and Movie Maker, then you can download a movie. You can create a movie and then open it in any movie playing program on your computer, say QuickTime or iTunes. So there's a lot of features that you can do here with Panoply. And I hope that you guys find these resources useful as you continue through the webinar.
But most importantly, I hope you find these resources useful as you go on and use Aquarius Data and use the PO.DAAC website. And you can put any NetCDF file into Panoply. So with that, I will turn it back to Dr. Santos, who's going to talk to you about accessing Aquarius Data.
Well, thank you for that very interesting presentation, Leslie. I learned a few things about Panoply that I didn't know myself. That was great. Okay, so in this presentation now, we're going to get to the nuts and bolts of how you actually start accessing and working with Aquarius data. Let me get my little pointer, and off we go. So again, the point of entry to all PO.DAAC resources is the web portal, okay? And the particular capabilities that we're going to be talking about in this presentation are FTP and a series of web services, including OPENDAP and Threads, and a set of PO.DAAC web services that have been developed for doing a range of things on data sets, querying data, subsetting data, and acquiring data, excuse me. So probably the simplest and everything that, something that everyone will be familiar with is FTP. You can simply use your web browser to go to our public FTP site, okay? It's an anonymous FTP site. Your browser automatically knows how to get into it, essentially. And then you'll see a series of directories. Things are organized by parameter. In this case, we're interested in salinity and density here, but there's also sea surface temperature and other parameters. Things are also organized by mission, so you can look for things for an Aquarius folder as well. So that's the first level. You can start drilling down sequentially through the hierarchy of folders and directories. And within the Aquarius sort of root level, you'll see that, that the data sets themselves are organized by level. So level 0 through level 3, okay? And in addition, there's a couple of directories where we maintain all the technical documentation that I talked about last week and that are referenced on the Aquarius mission page, in addition to the MATLAB and IDL reader software. Okay, so you can continue clicking through. So we are looking at level 3 now and the mapped. So you can see things are then organized by version. I just wanted to the current version, of course, is version 4 of the dataset. I just wanted to mention that since this slide has been produced, we have actually retired the version 2 and version 3 datasets. So if you were doing this interactively as I'm speaking, you would not see V2 and V3 listed anymore, okay? Those would occur in a quote-unquote retired subdirectory within the Aquarius root. Keep on drilling down. The next level is things are organized in directories by product time interval, as we discussed earlier. There's quite a few of those. And then the next level down, of course, is whether the product is a combined product or just the ascending and descending level 3 data. The next level down is then the time period, so the year, and then within that, the day-year directory for that data set. Okay, so once you finally drill down to the precise directory that you're interested in with the data that it contains, you then see a listing, and you have basically the various granules. Oops. Yeah, the various granules listed. And you can see there from our discussion previously, there's SSS, which is salinity, ancillary SST, density, and wind speed from the scatterometer. And you'll also notice that there's a second file that's similarly named for each of those categories with a .md5 extension. MD5 is not an actual data file. This is just a checksum file that ensures the integrity of the actual data file which, as I said earlier, is BZ2 compressed. When you uncompress it, the data file is actually an HDF5 file. So anyway, when you click on one of those data files, you're then prompted by your browser to download the data set. So this is great using your web browser, but it's not the most efficient way of bulk downloading data files. And for doing something like that, you probably want to use a specialized FTP client tool. I use a program called FileZilla that's available freely. And essentially what it allows you to do is simply by dragging and dropping from a remote FTP directory at any level, okay, you can just drag that across to your local destination directory, and it will automatically download all those granules in one go. So it's an efficient way of getting to the data and getting it onto your hard drive. Other features of this FileZilla tool is that it allows, you can do filtering of file names, so you can only download things that match certain regular expressions that you define for file names. And then it has a nice feature for managing the login information for various FTP sites. Okay. The final way that you can use FTP is essentially via your operating system command line. And I mention this here because if for those of you who want to get data on a routine and automated basis, you'll probably want to create scripts that run on cron jobs, that do scheduled downloading of data. And essentially FTP in combination with the mget command will allow you to do that. Okay? So essentially the syntax is given here. It's preceded with the anonymous login, and the password is simply your email address. Okay? And the screenshot just illustrates that sequence. Once you've actually gotten into the FTP site, you can then CD or navigate to the directory of choice. LS will list the directory items, and then you can begin downloading files. Now, if you're going to be downloading multiple files, you probably want to proceed with the command prompt N, which means that you're turning off the prompt that will otherwise come up every time a new file is getting ready to be downloaded. You have to press yes, Y, each time. So you want to avoid doing that. So by providing a prompt N command, it basically will automatically download all the BZ2 files that you specify with this command here. Okay? And again, you can use, here I'm using a wildcard to get everything in that directory, but you can apply other kind of filters in the file name filters in order to get the select items that you're interested in. Okay, so that covers FTP. I'm sure everyone is pretty much familiar with that. But in a way, it's not the most elegant way of accessing data and querying metadata as well, or doing subsets of data, because you have to, first of all, download potentially a time series of global data files. And say you're only interested in a particular region, you still need to download that data file and then extract the portion, the information, the portion that you're actually interested in to start working with it. So web services is an alternative and much more sophisticated way of accessing data, querying data, and downloading it. For those of you who may not be that familiar, a web service is essentially an application programming interface that can be accessed through standard web protocols such as HTTP to undertake some kind of operation on data. And that operation can be defined by a series of well-defined parameter extensions in that URL that's specified. And this is the general form that a web service request or URL will take. HTTP, as we said, the server that's being accessed, potentially a path to that web service, and then the particular web service accessed, and then the range of parameters defining your query. Okay, so that's the general form. And of course, the fact that it is an HTTP request means that you don't need any specialized software to execute this command. You can simply execute it, copy and paste the URL directly into any web browser, and it will execute from there. So the utility essentially, though, of web services is that it allows programmatic calls over the internet to a service via standard HTTP request. It allows automated machine-to-machine data access and queries. Okay, you can request not only data or subsets of data or do some operation on the data and extract and download it, but you can also query metadata, okay, at the at either global or variable level metadata to return that as well. And essentially what you get back is some kind of data object. It could be an XML output, JSON output, a data file, or an image file. So increasingly more tools now, and this is a screenshot of the live access server visualization and subsetting tool. Basically, at the back end, what you're doing when you make your GUI selections, okay, your selections on the user interface, on the back end, what is executing is actually a web service request. So, you know, you can essentially create client tools, such as LAS, that will be able to access data via these web services that PO.DAAC serves data through. Okay, so now let's look at some of these web service technologies that we support at the PO.DAAC. Probably one of the easiest to get to grips with, and perhaps one of the most useful for most users, is Threads. And Threads is a web service capability that's been developed to aggregate, serve, and allow subsetting of earth science data. Okay? Now, in Threads, one of the key aspects is this aggregation. Okay? You can create these catalogs, these Threads catalogs, that are logical aggregations of data sets and data granules. And the way we organize things at the PO.DAAC, okay, and this other data centers could organize things in different ways, but for a given data product, okay, of an entire time series of all granules for that data product constitute an aggregation catalog, okay? So here we see two URLs that you can click on. Actually, all of these, I'm not going to do it here because that would launch, you know, an application, the web browser. But when you download these slides, you can definitely try it out, and they will take you directly to the location on the PO.DAAC portal that hosts the Aquarius Salinity and Wind Threads catalogs. And this little screenshot here shows some output from what you would see when you click on the Aquarius Salinity catalog, okay? And you can see the different data products that we mentioned earlier, okay? And if you then click within one of these, this allows you then to get the entire time series of data that Threads is serving out for that particular collection. So one of the other advantages of Threads, in addition to dealing with these aggregations of granules, is that it allows subsetting of gridded data by value. That is with respect to latitude, longitude, and time. Okay, so you can specify those as query parameters. And in addition, even though the data may not be are natively in HDF, you can output them in different formats, such as NetCDF. So this slide just shows you, once you now click on that particular aggregation, okay, in this case, a 7-day salinity product from Aquarius, okay, what comes up is a form, okay, the NetCDF subset service, okay, form, where you can basically interactively specify a bounding box and a time period for which you want to query that catalog, okay? And what you'll get back is a single data file that aggregates all the results for that area of interest indicated by the screenshot, okay, for the entire time period. So you get back a really nice compact package that then you can work with, okay? So this is the graphical way of invoking a threads query. But again, what underlies this web form is actually a web service request that looks like this, an extended URL that can be decomposed into, very understandable elements. There's the HTTP portion, request to the server, okay? There's the reference to the catalog, okay? Then you have after the question mark, you have the particular variable that's being queried, the variable list, and it could be more than one variable potentially, the bounding box filters, and then the time range that you want to specify in your query. So again, an example of querying by value that Threads makes very easy to undertake. Another type of web service technology for serving out and subsetting and delivering earth science data is OPENDAP, and many of you may be familiar with it. It's a little bit more complicated to use because it is based on, it is index-based subsetting at the granular level. So for the user, you need to understand how the data is actually organized in data arrays so that you can specify index ranges to undertake a subsetting query, okay? And each of these operations works on individual granules. So in order to process a time series, you would have to submit a series of OPENDAP requests for each granule in that time series. So this is an important distinction between OPENDAP and Threads, and an example of why Threads for gridded data, okay, is a lot easier to use, for the uninitiated user. Okay, so anyway, for Aquarius, we have a link to where you can access all Aquarius data via OPENDAP, okay, by level, and Leslie explained some of this, okay. So you can drill down ultimately, and then you get to the granule directory basically, and then there's a further step. You can click on that individual granule and expose metadata, okay, all the metadata, both global attributes and variable attributes associated with that data file, okay, and then you can basically download it in a couple of formats, or before downloading it, you can select to omit certain variables, and it's hard to see, but there are these little dialog boxes here where you can specify array ranges, okay, that you want your extract to include. So by default, okay, this is the entire data array, but you can go in here and say, look, I'm only interested in certain latitudes and certain longitudes, and I want to skip every second grid point, okay, by the step parameter here. So then you can specify that. The query then appears in this URL box, and you can copy and paste it somewhere else. Or you can just then execute that query with the subsetting invoked and get just that exact portion of the data file for your region of interest, okay, if you're working on a regional study. Again, this is the form, but what is going on the back end is a OPENDAP web service request, again, with this sort of extended URL. And again, it's very straightforward to understand the structure of this. Once you've looked at a couple of these things, you'll get the hang of it. So essentially, again, there's the HTTP request to the OPENDAP server at PO.DAAC, okay? Pointers to the particular granule. Again, OPENDAP works at the granule level, okay? And then you can see here that you can specify an output format for the extracted data that you're going to get. After the question mark, the variable list, in this case only one variable, the L3M data array, and then the portion of the data array that you want to subset. As you can see, I'm not taking the data array in its entirety. So that's it for OPENDAP. The final web service that I just wanted to point out very quickly is a range of web services developed at PO.DAAC for querying metadata, okay, in our catalog database. And this is both granular and dataset level metadata. You can get at any of that, okay? There's essentially a range of commands that are available, and again, a web form that will illustrate how that web service is invoked. And this slide here just demonstrates how you can chain a series of these web service calls to use then the output of an initial request and feed that into a subsequent web service request where you get more detailed information. So later on you can study this workflow if you like and actually try it out, and it will show you how you can get from querying just the keyword based, an Aquarius keyword. This first operation effectively emulates exactly what we did on previously on the web portal, right? When I queried for Aquarius and got the listing of data sets, this is exactly what's executed on the back end, and you get a listing of these files. So you can continue through this chain and then see how you can get to very detailed information on even Aquarius data files. And so this is my last slide, and I'll let you guys study it on your own when you're in your own time. But it basically summarizes what these various web service capabilities do, their pros and cons, their ease of use. Okay, so depending on specifically what you want to do, your level of technical expertise and comfort, you may want to use this as a guide to which web service to use. And that's about it for my presentation. I'll hand it back now to Annette, I believe.
Thanks, Vardis. Yes, that was very interesting. A lot of techniques on ways to get at Aquarius data. And speaking of that, I'm going to do a quick preview of this week's homework. Those of you who did it last week, again, we thank you for doing that. If those of you who did not do it, you're welcome to start trying the homework this week. And so let me describe it right now. So, but before I get there, I just want to, why are we giving you homework? What's the point? Well, we want to reinforce the content presented during the webinars and practice using various types of tools. You've heard a couple of times the tools that we're presenting are all cost-free, so it's nice to have these things at your fingertips. No, you don't have to spend any money, and it can really help you accomplish your goals. The wiki that we post the homework on allows you to give and receive feedback in a friendly atmosphere, and then it's going to help prepare you for the virtual poster session if you elect to participate in that as a presenter. What's the level of commitment? Each week's assignment should take less than an hour to complete, and they are due the week before next week's webinar. So, session 2 homework. First of all, please comment on students' other week 1 homework. It's always nice to get feedback, and so if you can go back and look at other students' week 1 homework and give your thoughts, I'm sure it would be appreciated. The new assignment is to use PO.DAAC salinity data and the Panoply software to create one of the following: a longitude-latitude plot, a line plot, a Hofmahler plot, a combination plot or a combined plot, or an animation. As Leslie mentioned in her presentation, Panoply was just a delight to learn, and she really, really liked it and felt it was very powerful, and we think you will feel the same way. It's kind of getting you used to working with the data, and I'm sure you'll find it very straightforward to use. The step-by-step videos that Leslie has talked about and also put together are all there on the wiki for you. There's a little screen grab to the right showing you how they're set up, but the 11 that she talked about are there at your convenience, and you could just go and look at those if you have any questions or if you just want to find out what's available to you. The other thing we'd like you to do on the wiki is to share your thoughts on the process of downloading the data, working up the data. Was it easy? Was it difficult? Was it fun? Was it not fun? It always helps us to know, since we do know a lot of the people who are creating these tools, so we can share the feedback with those folks. So we would appreciate any thoughts on that as well. So good luck on the homework, and feel free to ask questions during the Q&A session. Before we get to that, we'll have a poll question that Jennifer is going to administer, and I also want to get folks excited about next week's webinar, which we are going to talk again about some visualization tools from PO.DAAC, and I will share some of the tricks and tips that I've learned on how to do scientific communication effectively, and those will also be online tools that you'll be able to take advantage of, and I think you'll like doing that. So thanks so much, and I'm turning it over to Jennifer.
Okay, thanks, Annette. Thanks, everybody. So what we've got here, you've already started. That's wonderful. We've got a couple of polling questions. We will give those 2 minutes, and from there we will transition to the question and answer period. And if you look in the lower right-hand corner of your screen, everybody, you will see that I've got today's files, the homework review, the preview, the outline, pretty much anything that was presented today in both PDF and PowerPoint format. So the way that that works is that you will highlight the file and you will be prompted to download those files. Not to worry if you don't download it right now before we jump to Q&A, because you will have an opportunity to download the files within, by clicking on the recording that will be posted to our online catalog. We've been posting them also to the wiki, and they will, well, they won't be posted to YouTube, but certainly the recording will. All right, so let's give these a couple of minutes here. We've got about a minute left, and from there we will move directly to the question and answer period. All right, thanks everybody. Okay, everybody, with that, we will move to the question and answer period. And you'll notice that I've posted some information here. Again, for those of you who have not signed up to the wiki, there are some instructions for signing up if you do not already have a URS account. If you've ordered PO.DAAC data before or other data from a different data center, you most likely will have a URS account. If you run into any difficulties, you can email me, and I can work with the support team for the Earthdata to get you set up. All right. So let's see if we've got any questions here. All right. Okay, so the first question is, I'd like to ask why, to what purpose would one use only the ascending or descending parts of the swath?
So these, those particular data sets, the ascending and descending, mainly used in the cal-val process for trying to identify certain sort of errors, or uncertainties in the Aquarius data. So it's, for the typical user, it will not be of particular use, but it's mainly a product that's produced for those who are more advanced users who are looking at potential artifacts or quality issues in the data.
This is Annette, and I'd like to also add to that that there is a document that was presented last week. It's called the Aquarius Salinity Validation Analysis, and it's from the folks at Earth and Space Research, and they do cover some of the issues related to ascending and descending data passes. So I would recommend that you read that. It was again in last week's materials, and I believe, and Bart and Jorge, correct me if I'm wrong, it's called the Validation Assessment, and it's by Gary Lagerlof and Sung-Ying Kao.
Hi, yes, this is Jorge, Annette. Just to add a little bit, one of the reasons that the data is split into ascending and descending is because, as Vardas was saying, there are errors associated that are specific to an ascending swath or descending swath. So what you want is the actual signal that, salinity is basically how it's changing in the ocean. So, but to do that correctly, you need to really get a handle on these errors that are in the data, and part of those errors are associated differently with ascending and descending. So that, and as Annette was saying, all of that is explained very, very well in the validation document for those that are interested.
Okay, thank you, Jorge. All right, let's see here. I was disconnected. We're having a heck of a time here in my office building today. No phone services and no, just got disconnected, but we're back up. And the follow-up question is, what is the distinction between a data set and an aggregate?
Well, you know, these are somewhat generic terms. A data set is essentially a data product. That's how we define it at most of the NASA DAACs and certainly at PO.DAAC, okay? So a particular data product in the case of Aquarius, say a level 3 7-day data set, that data product is you know, is a discrete entity, and so all the granules associated with that comprise a collection, okay? And yeah, so a catalog is essentially a collection of potentially data sets and or granules, okay? And this notion of a collection is really a concept that applies to threads, is kind of specific to the threads web service that I described in my presentation.
Okay, wonderful. Thank you, Vardis. Are there any additional questions? As we are waiting for additional questions, just want to remind everybody, especially if you weren't here last week, then this would be new information. So generally the way that this will work, you know, pending any further questions, of course, but when we're finished here, we will log off from the telecon, and then I will leave the virtual meeting space open an additional 10 to 15 minutes so that for those of you who might be interested in downloading the files, and I'll switch it back to, you know, that layout so that you can, you have an opportunity to do that now, okay? Are there any further questions from anybody? No further questions? Just give it another minute or so. Well, I would like to thank everybody for joining us. It looks like we've got, you know, some really good high level of participation from last week's participants to, you know, participating again this week, and that's wonderful. Annette or Carla, did you have any parting words before we, you know, log off from this week's training session?
Sure. Again, I'd like to thank everyone for joining us, and I think that last week you learned about the data, how they're acquired, and through your homework you got to see some of the patterns and also some of the videos that Tony showed. So we're starting off by getting you familiarizing with Aquarius. The next step is giving you some tools to go and grab some of the data from the PO.DAAC and make some plots yourself that'll help you in your research. And then the next step will be learning how to communicate effectively about the science that you are trying to share with other people. And then the last session, of course, will be the poster session, and we would really love to see some of you participate in that, and we promise it'll be fun. And so thanks again for your time, and if you have any comments or questions, make sure to ask us. And again, on the wiki, on pretty much every page, there is a contact email. So thank you again.
Okay, thanks, Annette. There actually is another question here. What is the definition of raw data? Is it the brightness temperature, or the sea surface salinity without correction?
No, so when we talk about raw data, we're talking about the level 0. Okay, so this is the actual data coming down from the satellite, which is at a lower level than even the brightness temperature data. Okay, yeah, which are the counts. So does that answer your question?
Laura, does that answer your question? If not, okay, great. All right. Are there any further questions? It does not look like it. So with that, if I don't see another question pop up here in the next few seconds, we'll log off the telecon and we will see all of you online next week and dialed in. And I look forward to your homework and your participation. All right, well, thanks, everybody. We're going to hang up from the phone line now, and then what we will do is, again, leave the virtual meeting space open. I need to go back to the layout where we've got the file sharing pod, and certainly if you have additional questions, you'll have an opportunity to ask them during that time period as well. So thanks so much, and we'll speak again next week. All right, bye-bye, everybody.
Bye.
Bye. Good luck with your phone.